In this video, we are going to talk about finding domain algebraically, and then I'm going to also have another video for symmetry and then asymptotes to try to break this lesson up a bit here because it's going to be pretty long if I do it all in one video. So let's take a look. We talked about domain earlier, about how domain is just all of the input or the x values. Another way to think about domain is all of the numbers that mathematically work for a given function. So if there's any operations that don't work mathematically, they can't be part of the domain. So specifically for us right now, we're going to be talking about dividing by 0 and then square roots of negative numbers. Those are the two things right now that we're going to be talking about that don't work. Like you can't do 5 divided by 0 and you can't do square root of -5. So if you ever have division by 0 or square roots of negative numbers, those values do not work in the domain. So just make sure that you're asking yourself that when you're looking at functions, okay? So as you get an equation, just ask yourself quick, could it ever be dividing by 0 for any x values, or could there be negative roots? And if you ever see those, then you need to deal with that for the domain. So for instance, if you see a function, okay, and it has any number on the top, so I'm just going to put number, it could be anything on the top, and then divided by something, okay? So if you ever see division down here with a variable like x plus 7, x, squared minus 2, anything with a variable down here, that's potential for dividing by 0. In which case, then you have to get rid of those numbers from the domain. And I'll do some examples, but if you have anything down here, okay, you're going to take whatever's down here, whatever the stuff is. Let me just write stuff in here. So whatever this stuff is cannot equal 0. And that's going to be how you solve for your domain, no matter what is in there, okay? That will be the formula or the thing that you do. Set it not equal to 0, solve. And then is there a square root in your function? If there is a square root, okay, so if in your function there's a square root anywhere, we cannot have what's under this root be less than 0. Okay, so whatever's under this root, if you ever see a root, you have to take what's under there and say that chunk, okay, needs to be greater than or equal to 0 in order for it to work. Okay, quote unquote, work mathematically. So whatever this is, we can do the square root of 0, it's 0. We can do the square root of any positive number, that's fine. We can't do the square root of a negative. So your domain is going to be all of the numbers that make this thing greater than or equal to 0. Okay, and if you have division by 0, all of the stuff where that's not equal to 0. So let's take a look. So in this one, again, we'll ask ourselves, can we ever end up dividing by 0? The answer is no, there's no division here. Okay, then the next one is there a square root? And of course, we do see that there is a square root here. So we're going to take what's under the radical, okay, and we're going to take that stuff and say that stuff has to be greater than or equal to 0 for this function to work. If this ends up being less than 0, then we have a problem. Okay, so then you'll just go ahead and solve this. So we'll just subtract 3 from both sides and get that x has to be greater than or equal to -3 is our domain. Those are the good values. So I'm just going to quick draw that on a number line so that we can do the interval notation a little bit easier. So remember, this is how you probably did it in Algebra 2. We need to do interval notation. So I'm just going to draw on the number -3. And now I need x's that are greater than or equal to that. So I'm going to draw a circle and close it there because it can be equal to -3. And then it needs to be greater than that. And then this is going to help us with our interval notation because if it can be equal to it, then it's a hard bracket. And now we're going all the way up to this number way up here, which is infinity. So our interval notation for the domain is going to look like this. Hard bracket -3 up to infinity. Those are all of the numbers that will work for this domain. Then you can check it graphically. So then graph it and see if that makes sense. So left to right, this is the graph of that function. So we see the x's start here at -3 and go forever to the right, so up to infinity. So solve it algebraically and then quick graph it and check it. Okay, so this one, do we have anything in this function that we could end up having division by 0? Okay, so we do have a denominator here and it does have a variable. So we have this chunk that cannot equal 0. Okay, if we end up with 0 here, we have a bad domain value. So we need all of the numbers that don't make this 0. So solve, add 5 to both sides. So 5 cannot be part of our domain. Everything else is fine as far as division by 0. So this is one part of our domain. Then the second question that we needed to ask ourselves was, is there a square root? And we do see a square root here. Okay, so for the square root, you need to take what's in the middle or underneath the square root. And we can't do square roots of negative numbers. So we need that number to be greater than or equal to 0, and then that's good. So that's already solved. So these two pieces right here are our domain. So let's graph those on a number line so that we can do the interval notation quickly. Okay, so I'll just draw this number line. Again, down here you have -infinity, up here you have +infinity. And now we need these two numbers, 0 and 5. So I'll put 0 here, 5 here. So we can't have 5 because that gives us division by 0. So I'm going to just put an open circle on 5. I'm not going to fill it in because it can't be equal to 5. This just says x cannot equal 5. Open circle right there. Everything else is good. Okay. Now this one says that x has to be greater than or equal to 0. So it can be equal to 0. So I'll draw a dot and fill it in. And I need the number to be bigger than 0. So everything up here. Okay, remember it couldn't be 5. So I'll skip that. Okay, has to be greater than or equal to 0 and not 5. So now when you go to do the interval notation here, okay, it's equal to 0, so that's going to be a hard bracket on 0, comma, up to your next one, 5. It cannot equal 5, so that'll be a soft bracket. Then we have another chunk, okay, this split it. So now we're going to do that little u to say also, and it restarts right at 5, but not equal to 5, so open bracket, comma, up to infinity. Never reaching infinity, so a soft bracket again, and this is your domain. So you can only have x values from 0 to 5, skipping 5, and then 5 to infinity. So let's take a look at the graph here to confirm. So we see nothing down here where x is less than 0. Okay, so no domains down here. We go from 0 to 5, and then we've got an asymptote at 5. So 5 is not part of it, and then it starts over. So 0 to 5 and then 5 to infinity. One more here. So this one is an area function. So area in relation to the length of a side. So this says where A of S is the area of an equilateral triangle with side length S. The only reason that that's important is because now we're talking about a triangle. So what can the lengths of the sides of a triangle be? They have to be positive numbers. Okay, you cannot have a 0 length side, and you cannot have a side less than 0. So this square root is fine because it just has a 3 under. There's no way for that to be a negative number. Okay, so if we didn't know that this was a triangle, this would be all real numbers for the domain because there isn't division by 0 and there's no square roots of the variable. However, because of this, the fact that it's an equilateral triangle side length, then the side needs to be greater than 0, not equal to 0, because you can't have a 0 length side. Okay, so your domain looks like this, 0 up to infinity. We can look at the graph here. However, the graph for this one would suggest all real numbers. Again, because it's an equilateral triangle, we can't have any of these negative numbers. So this would be our domain when it's in regards to a side length of a triangle. Okay, so why don't you pause the screen and try these 3 examples, and then you can hit play again and I will go over them. So I'll give you a second to pause. All right, so when you're doing this first one, again, start by asking yourself, is there division by 0? No. Is there a root? Sure is. Okay, so this piece in the root, because we cannot do division by 0, or sorry, because we cannot have negative square roots, this piece has to be greater than or equal to 0. So you would solve that. So subtract 3 from both sides. Divide by 2. So x has to be greater than or equal to negative 3/2. Remember, the only time you have to worry about this inequality is if you multiply or divide by a negative number. If you do, then you switch it. Okay, so the domain here is x's that are bigger than negative 3/2. So if you quick looked at a number line here and drew that, negative 3/2, you want bigger than or equal to. So this way. So when you do the interval notation, you would have a hard bracket on negative 3/2 and be going up to infinity. The graph will support this, showing you that negative 1.5 up to infinity, so to the right there. This next one, is there division by 0? No. Is there any radicals? No. So that means that your domain is all real numbers. There isn't anything that is impossible to put in here. So all real numbers can go in there. The graph will support this by seeing an arrow to the left and an arrow to the right. Final one here is, do we have division by 0? The answer is yes, we do. So we have 2 pieces on the bottom here, okay? So this cannot equal 0, this whole thing. Well, we know from the from Algebra 2 or even Algebra 1 that when you multiply 2 numbers together, the only way they equal 0 is if one of them is 0. So one or both. So we're going to set both of these equal to 0, both of these factors equal to 0. If this were a quadratic, if this were written out as x squared plus 2x minus 8, we would have needed to factor it to this so that we can solve. So add 2 to both sides. So 2 is going to make the denominator 0, okay? So we can't have 2. And subtract 4 from both sides. So we can't have negative 4. So those are the 2 bad values. So again, if you wanted to just quick look at this on a number line, the only 2 values that are bad are negative 4 and 2. So we cannot have negative 4, so open circle there. We cannot have 2, open circle there. Everything else you can have. My computer froze. Okay, everything else you can have. So then remember that this number down here is negative infinity and this number is infinity. So now you can just add in the brackets. So we can never get to negative infinity. So we're going to go soft bracket negative infinity to negative 4, not including 4, so soft bracket. Then we need to restart just after 4. So a u and then that soft bracket negative 4 all the way up to 2, not including 2. And then from 2 up to infinity. So we have soft brackets all along all of this. And then this would be our domain. So let's take a look at what that looks like on a graph. So you see asymptotes at negative 4 and 2. So we see these breaks in the domain. Whoops. So negative infinity to negative 4, negative 4 to 2, and then 2 to infinity. So the only 2 bad values in this whole function are negative 4 and 2.